Welcome to Lee's Science Academy, a study room where you don't just memorize but understand systematically and logically through the whole picture. In the last two sessions, we studied how knowledge is created based on the abstraction ability and logical thinking of the human cognitive system, and further learned about the logical laws and proposition-proof methods we can rely on when thinking logically. Today, in the third and final Humanities video titled Classification of Knowledge and Absolute Truth, we will analyze the contents of the knowledge we obtained to find out what it really means to know, and whether absolute truth exists. Here is today's video composition. First, we define a few terms. We will examine whether the object or entity of experience actually exists, its reality. We will analyze the content of inductive knowledge to see if the knowledge obtained inductively through experience is really correct, or if we mistakenly think it's correct when it's actually wrong. We will explore why deductive knowledge requires an axiom or base assumption, and what is called authoritative knowledge separate from inductive and deductive knowledge and its limitations. We will learn about human memory ability and the brain knowledge stored in memory. We define absolute truth and find the conditions for it to be established. We define terms. Terms are the results of abstraction and the starting point of the act of knowing. If you do not understand definitions accurately, the content of knowledge loses its logic and system, falling into confusion. Please understand definitions well. Knowledge. We defined knowledge earlier as a widely accepted true proposition. The phrase widely accepted implies collective or universal knowledge, not just personal knowledge. Inductive knowledge. Defined as knowledge whose proposition is proven true by experience through induction. Deductive knowledge. Defined as knowledge whose proposition is proven true by logical deductive thinking with the structure of conditional statements. Axiom. A proposition that is accepted as true without proving it to be true. Euclid's axioms of geometry learned in demonstrative geometry are not proven. Base assumption, the very first axiom in a continuous deductive structure. Since the first proposition in an ongoing deductive structure cannot end unless proven true, it is finalized as a base assumption. Discipline. A systematized collection of knowledge. Not all learning is called a discipline. Only systematic learning can be called a discipline. Science. A knowledge system based on real phenomena equipped with the logic of cause and effect. Causality is important. Knowledge lacking causality does not become science, and doing science is the process of finding causal relationships. Let's examine if the object of experience actually exists in reality. Inductive knowledge proves truth through experience, so experiencing is a prerequisite. Experiencing is generally the process of confirming an object through human senses. Looking at this picture and asking, "What is on the desk?" you answer, "An apple." Asking, "What is the color of the apple?" you answer, "Red." If asked how you know there is an apple here, you say you know because you saw it with your eyes. Then how about this question? Is it not there if you don't see it? Doesn't the apple exist for a visually impaired person who can't see it? The visually impaired person would say they can know by touching it. Then does the apple exist for a person who lost both sight and touch due to an accident? Without sight and touch, they say they can know by smelling the apple. Then does it exist for someone who also lost their sense of smell? As an extreme case, does the apple exist even for a person who has lost all five senses? To put it extremely, if the entire human race did not have the five senses, would the apple exist objectively to humanity? We are currently dealing with the difficult problem of reality or existence. Let's assume one more case. There is a room, and an apple is on a desk in that room. Visible light is entering this room, and infrared rays are being emitted from the desk and apple. In this state, do the desk and apple exist for a person in the room? Yes, since they are clearly visible, they will say they exist. But in reality, if visible light is blocked, it is invisible to human eyes. If there is another organism or infrared camera that detects infrared rays, that organism could perceive the existence of the desk and apple. Let's change the expression of the question here. Does the object sensed by a human actually exist? If something has mass but does not interact with light, does it exist? If such a thing exists, it is an abstract existing only in the human mind. I won't discuss this further here, but there is an aspect where we can't easily answer that what humans sense actually exists. Let's examine one more thing from a different perspective. You might have heard it at least once, but light has both particle and wave properties. Then what is the reality? Is it a wave? Is it a particle? In quantum mechanics, due to the observer effect, it is said that it is not determined until observed. In Lee's Science Academy, we maintain the position that the first fundamental essence constituting the universe interacted with the first entity created after the Big Bang, configuring the universe in the same state as the first entity. It's very difficult, right? According to this position, the shape and structure of the universe are determined by the first entity, and the universe where humans exist had atomic units like elementary particles as the first entities. So humans are composed of atoms, and the human universe also constitutes a world with atoms as reality. Is it too difficult? It would be good to think about it with time instead of trying to understand it all at once. As we saw in the previous video on the human cognitive system, the universe does not exist separately from humans, but is a subordinate entity created by humans. The reality of an object is a very difficult topic. Since Lee's Science Academy is a classroom delivering basic knowledge to students, unless specifically mentioned, we maintain the position that the object perceived by humans through sensory organs, according to the human cognitive system, objectively exists independently of humans, and we accept expressions about that reality as correct. So we accept the proposition the sensed object exists as true. Therefore, what is visible is real. You can say it exists because you saw it, and you believe it. Now let's find the answer to the second question. What is the color of the apple on the desk? In question 1, we perceived the apple and knew the apple actually exists. Here we will find the answer about the color of the apple existing like that. If you answer red to this question, it is correct, and if you say green, it is wrong. Here I want you to pause the video and think about why red is the correct answer and green is the wrong answer. As you will learn in physics and life sciences later, color is not an objectively existing reality. The reality is the electromagnetic wave, light, that we sense. Color is an abstract created by the combination of light and the human cognitive system. In philosophical terms, it is a representation of perception. When we receive light with a wavelength of 650 nanometers through our eyes and send that signal to the cerebrum, our cognitive system interprets it and assigns the color red. If it was named blue instead of red when first named, it would have been blue. Of course, if light of 530 nanometers enters, it would assign green. Since human sensation is created by the combination of an object and the cognitive system like this, not only color but also sound, smell, taste, and touch are not objectively existing, but are abstracts created by the human cognitive system. The eyes, ears, nose, tongue, and body are receptors and do not have perceptual ability themselves. The following table is a sensory classification table from a life science textbook. Please pause the video and take time to look at the contents. Sensory organs consist of eyes, ears, nose, tongue, and body, but they are just receptors of stimuli and cannot sense by themselves. When a sensory organ sends the stimulus received through its receptor to the cerebrum, the cognitive system interprets that stimulus and assigns sensory content. What actually exists is a stimulus acting on a receptor like light, and sensation is an abstract obtained as a result of perception in the cognitive system. Eyes use the visible light portion of light as a stimulus, combine it with the cognitive system to sense color or shape, and ears use sound waves as a stimulus, combine it with the cognitive system to sense sound. The nose uses gaseous substances as a stimulus to sense smell, and the tongue uses liquid or ionic substances as a stimulus to sense taste. The body's skin uses pressure or touch as a stimulus to create a sense of pressure or contact. Please remember that sensory contents like color or sound do not actually exist, but are abstracts created by the human cognitive system by distinguishing them from others. We accepted a moment ago that what is perceived through the five senses is real. For the same reason, we also accept the sensory contents recognized through the five senses, such as color, sound, smell, taste, and touch, as correct. Therefore, the apple's color is red, and the sound you just heard is a piano sound. Also, the perfume smell recognized by the nose is correct, the sweet taste recognized by the tongue is correct, and the hot feeling recognized by the body is correct. In conclusion, we judge the contents learned through the five senses as correct and accept them as knowledge. Since knowledge obtained through the experience of the five senses proves truth inductively, Lee's Science Academy classifies it as inductive knowledge or sensory knowledge. Of course, the five senses also include sensory organs expanded by human civilization, such as telescopes, microscopes, oscilloscopes, bubble chambers, CT, MRI, PET, etc. Let's look specifically at the sensory organs expanded by human civilization. As a telescope, this is the Hubble Space Telescope. Launched in 1990, which is 31 years ago from now, the observable wavelength range is 115 nanometers to 2,500 nanometers, including near-ultraviolet, visible light, and near-infrared. It is said to be still working well after several repairs. This is an electron microscope. This is a high-resolution electron microscope image of the COVID-19 virus released by the Korea Disease Control and Prevention Agency. You can even observe viruses with an electron microscope. This is a bubble chamber. It is used to observe elementary particles. The left photo is a bubble chamber at Fermilab. It is a photo of the track of an elementary particle flying, first observed in a 3.6 centimeter liquid hydrogen bubble chamber in 1954. Through this photo, the existence and reality of the elementary particle are confirmed. The right photo is a bubble chamber at Fermilab, with a size of 4.57 meters, which is said to be currently not in use and exhibited as a relic. Please compare the sizes 4.57 meters and 3.6 centimeters. Oscilloscope. It is a tool that visualizes waves. Medical equipment includes CT, MRI, PET, etc. You will hear these terms often in daily life in the future. Here, a positron is an electron that has a positive charge, unlike a regular electron which has a negative charge, hence it's called a positron. From now on, let's look at deductive knowledge or logical knowledge. Deductive knowledge is something learned by proving a proposition's content is true according to deduction. Since deductive knowledge takes the conditional form of if P, then Q, we examined in the last video that it is a method of creating new knowledge Q based on the true knowledge P. We examined the thought process of newly learning that Socrates is mortal in the syllogism example in the last video. Humans are mortal is the true proposition P. Socrates is a human is also the proven true proposition Q. Therefore, Socrates is mortal becomes the new true proposition R. This logic has the structure if P and Q then R. In this logic, proposition P was proven true by induction, and proposition Q was proven true according to the logical law of identity. How can we prove the truth of a conditional proposition purely using the structure of deduction? We can prove the truth of the hypothesis proposition by deduction. If P1, then P. How do we prove the truth of P1 again? We prove it with if P2, then P1. How do we prove the truth of P2? We prove it with if P3, then P2. Continuing in the same way, the inference goes on endlessly. You can construct propositions entirely within a deductive system from beginning to end. Within this deductive system, you must understand well that P of n plus 1 derives the truth of P of n derives the truth of P of n1, and continuously down to if P, then Q. All propositions down to Q become true propositions. How should we prove the truth of the very first proposition? Another solution is devised. It's a very simple method. The very first proposition is assumed to be correct. You just continue the inference backwards. Since the deductive structure cannot be finished if the inference continues endlessly like this, if P of n plus 1, then P of n, and if P of n, then P of n1. Continuing this process, if P2, then P1, and if P1, then P, finally reaching the stage of if P, then Q. At some stage in the continuous deductive structure, if we assume the proposition to be true, then all subsequent propositions become true, and as a result we obtain a systematic and clear knowledge system. Let's classify such systematic knowledge as a discipline. The most representative one is mathematics. At this time, the first proposition assumed to be true is called an axiom or base assumption to distinguish it from other propositions. If an axiom or base assumption is accepted as true without strict proof, and a system of knowledge is built based on deductive logic upon it, it becomes a 100% abstract discipline based purely on logical laws, unrelated to reality. Mathematics, created this way, is a 100% abstract discipline based on axioms. Mathematics is a 100% abstract discipline based on inferential logic, but you can understand that all propositions within the deductive system are always true. Because mathematics has an always true deductive knowledge system, we easily answer 5001 to the following question. If you order a 25,001 pizza and pay 30,001, how much change should you get? If the pizza price of 25,001 and the paid 30,001 are correct, by performing a subtraction operation, the 5,001 change is logically correct too. Do you understand? As we saw in the syllogism earlier, if an axiom is not based on assumption, but proven by induction, wouldn't we obtain a systematic knowledge based on experience, phenomena, and reality, rather than an abstract knowledge system? in the deductive system, starting from Pn plus 1. If the axiom proposition is proven true by induction, all subsequent propositions become true propositions based on reality. It's also possible to use inductive true propositions during the deductive inference after the axiom. We classify this system of knowledge based on reality as science. A representative example is natural science, especially physics. To understand the knowledge system of science or physics more deeply, let's bring the example used in the laws of logic and proof methods. The proposition, if you kick a standing stone, the stone moves. We don't intuitively know if this proposition is true. Knowing if this proposition is true requires kicking it and checking empirically if it moves, but here we will prove this proposition is true deductively using physics knowledge. We know that Newton's law of acceleration, if a force is applied to an object with mass, its velocity changes, is a proposition proven inductively to be correct. Applying this law to the above proposition, we can change the deductive structure. We insert the law of acceleration into the middle. Then the deductive structure changes. If you kick a stone, you are applying force to the stone, and according to the law of acceleration, velocity must change. And since the velocity changes, the standing object with mass moves. Whether a stone is a mass object or not is another proposition and problem that needs to be proven separately. In reality, solving a physics problem is nothing more than learning physics knowledge like the law of acceleration and logically applying it to phenomena in your mind without actually doing it. You understand, right? Let's take one more example of a natural phenomenon. We know the Earth's interior is a hierarchical structure of crust, mantle, outer core, and inner core. No one has ever gone inside the Earth and checked it with their sensory organs, but we judge this content to be correct and accept it as knowledge. In this knowledge, we put the phenomenon that, quote, seismic waves were measured, P waves were detected, but S waves were not detected, as the conclusion of the inference to draw a true hypothesis. We will study the properties of seismic waves in detail during the wave section, but here we will just accept the content as it is. For this judgment, we apply the inductive knowledge that S waves cannot pass through if the physical state of the material is fluid. That is, if there is a fluid in between, S waves cannot pass, therefore we judge that there was a fluid in between. And based on this judgment, we infer that there is an outer core in a liquid state inside the Earth. Please understand that the knowledge of the liquid state was obtained purely through logical thinking and deductive reasoning. Did you notice that in this deductive reasoning, we premised that the converse proposition is true? The converse proposition is not always true, but here it was accepted as true. Since there is only one case, the converse became true. But we will look into this again during the math propositions section. Lee's Science Academy classifies contents inferred as correct by tracing logic like this as deductive knowledge or logical knowledge. Such logical knowledge corresponds to the conclusion of a conditional proposition. So far, we have found answers to questions regarding the reality and color of an apple using induction relying on senses. And we calculated change, predicted the movement of a stone, and figured out the internal structure of the Earth using inference relying on logic. There are questions we cannot know the answer to using these methods. In what year did the U.S. declare independence from Britain? A question about a historical fact. If we answer 1776 to this question, it is correct. And if we say 1876, it is false. Then how is it guaranteed that 1776 is true? You and I didn't live in that era, so we didn't see the scene directly, so we can't judge if it's true. Then how do we accept something we can't judge as correct? We don't know if 1776 is true or false, but historians research and tell us it is so so we trust the historian's words and accept the content as true. How about this question? Unlike historical facts, can a quantum computer be built based on quantum mechanics? This question is very difficult, but we answer yes. Why? Because authorities in this field tell us it can be done, so we rely on that authority and accept it as true. Lee's Science Academy distinguishes true propositions confirmed by authorities like this from others, and calls them authoritative knowledge. If an authority deceives the world or caters to the public with distorted studies, someday the authority will crumble, and authoritative knowledge will become false. So far, based on the method of proving a proposition's truth, we classified knowledge into inductive or sensory knowledge, deductive or logical knowledge, and authoritative knowledge. When inductive knowledge is needed, you just look at an apple and verify its reality and color. Deductive knowledge can be tested by applying force and seeing if velocity changes, and authoritative knowledge can be verified with an authority. Verifying knowledge this way every time is highly inefficient, so it would be good if we could store it somewhere and take it out whenever needed. Fortunately, human intelligence has a memory ability and memory storage, so we can store knowledge in the cerebrum. Lee's Science Academy distinguishes knowledge stored in the cerebrum as brain knowledge. Of course, brain knowledge consists of sensory knowledge, logical knowledge, and authoritative knowledge. One thing to note here is that brain knowledge is simply stored in a memory location, so if the memory is lost, the knowledge cannot be retrieved again. Also, since brain knowledge is based on contents recorded in the brain, if memory is distorted for whatever reason, it might have been a true proposition when stored, but becomes a false proposition when retrieved. Therefore, since memory is hard to trust, we must not forget that brain knowledge always carries the possibility of being wrong. So they say even in trials, if memory is the only evidence, its evidentiary value is not recognized. Here, we will distinguish knowledge and truth and examine if absolute truth exists. First, what is the difference between knowledge and truth? Are they synonyms calling the same concept by different names? We defined knowledge as a widely accepted true proposition. When we say truth, it includes the meaning of being correct, but we consider there is something else different from knowledge. In Lee's Science Academy, truth is defined as something correct, but not only correct transcending time and space, but also accepted as correct by everyone. According to this definition, today's knowledge can become a truth if it remains knowledge unchanged in the distant future, and if what is correct for Koreans is also correct for people of other countries. The former expresses the immutability of truth regarding time and space, and the latter expresses the universality of truth for humans. If any knowledge possesses absolute immutability and universality, such truth will be absolute truth. However, as we saw earlier, inductive knowledge has limitations regarding future uncertainty, and deductive knowledge has the limitation of requiring a base assumption. Therefore, we can conclude that absolute truth does not exist. Historically, the geocentric theory was accepted as truth for nearly 2,000 years, but was denied by Copernicus' heliocentric theory and became false knowledge. Newtonian mechanics also became truth for nearly 200 years, but is now limited to an approximation theory of relativity. If we can change the base assumption of deductive knowledge to an inductive fact, a true proposition, which is the cause of the universe's creation and the principle of change called the Big Bang, we can establish a knowledge system post-Big Bang without a base assumption and obtain an immutable truth across spacetime. We overcome the limitations of deductive knowledge to satisfy one condition of absolute truth, and if we secure universality for humans additionally, we can obtain absolute truth. How can we secure universality for humans? We saw earlier that the universe does not exist separately from humans, but is a subordinate entity created by humans based on the human cognitive system. However, human mentioned here is a common noun, so there is no guarantee that what is right for me is also right for others. The human cognitive system is not created randomly, but by a precise program called genes. Also, the program of the cognitive system possessed by humans is common to all humans as a common noun. Therefore, everyone's cognitive system is the same, and as a result, a true proposition for one person is also a true proposition for all other people. If I have a red apple, others also have a red apple. In conclusion, the common genes of the cognitive system possessed by humans guarantee universality for humans. A priori knowledge in philosophy could mostly be replaced by common genes. Based on the discussion so far, the necessary and sufficient conditions for absolute truth are the secrets of the universe's creation and the common genes of the human cognitive system. The creation secrets of the universe secure the immutability of space-time, and the common genes of the cognitive system secure universality for humans. Since common genes are already secured, Lee's Science Academy maintains the position that absolute truth does not exist until we know the cause and principle of the universe's creation. Until we obtain absolute truth, there is only better truth maintained relatively longer, and humans are exploring and researching to find such truth. So far, based on the method of proving a proposition's truth, we classified it into inductive or sensory knowledge, deductive or logical knowledge, and authoritative knowledge, and examined that the immutability of absolute truth can be secured from the secrets of the universe's creation and universality by the common genes of humans. Contents about intuition, which is an innate cognitive function of humans, will be postponed to the next opportunity. As a method of finding truth or knowledge in science, the scientific method of inquiry, in other words the hypothetico-deductive method, will be explored in the science lectures. Through 3 lectures up to today, we briefly explored contents about epistemology. I am not an expert who researched this professionally, so the contents might be loose and lacking, but if it helps even a little to study science logically and systematically, the effort of making the video would not be in vain. Thank you for listening to the difficult content to the end. For the next video, as a preparation for doing science, we will prepare a video on basic mathematics. As the first video of basic mathematics, we will deal with the creation of natural numbers. We will end today's video here. Thank you.